Okay, so picking up the last page here with number 16, all right, we are doing another composition of transformations. And this time we are doing a reflection in the origin, okay? And then we're doing a translation of -6 fourths. Remember, when you see the circle, it means you got to work backwards. So we're doing this first, and then we're doing that one second, okay? So a couple different things to do here. If we're doing a reflection in the origin, remember, it's just like a rotation of 180 degrees. So we're just going to take our points, and we're going to switch the signs. So it's -x, -y. All right, so point A, which is the point -5, 2, B, -1, 7, and then C is 2, -1. We're going to change the signs, so we're going to get A prime to be 5, -2, B prime is going to be 1, -7, and then C prime is going to be -2, +1. And then we're going to do the second transformation, which is the translation. So we'll subtract 6 from 5 to get -1. Subtract 4 to get -6. We'll take B prime, and we'll subtract 6 to get -5. Subtract 4 to get -11 from B to get B double prime. And then for C double prime, we'll subtract 6 to get -8. We'll take away 4 to get -3. And this should be our end result here, okay? Now, how do we do that on a graph? That's the question. So if we start with point A, which is -5, 2, okay, B is -1, 7, and C is 2, -1. All right? So we end up with this guy right there. Now, if we rotate to the origin, right, reflect to the origin, it means we count to the origin and we do the same move past. So there's C prime, and that's our -2, 1. So B would be down 7 and over 1 to the right. So we're down 7 and over 1 to the right, and there's 1, -7. And then C prime, or sorry, A prime, we need to go 5 over and then down 2. So 5 over and down 2, and there's A prime. So this is what that is going to look like. Okay? And there's our reflection through the origin. And then the last one is to translate it, which means we go 6 left, so 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. That's where C double prime is going to go. We're going to go 6, 2, 3, 4, 5, 6 to the left, down 4. That's where B double prime is going to go. And then 6, down 4. That's where A double prime is going to go. And just make sure that you're labeling the points on the graph with the right primes. And then you're also labeling your points. Okay? And that would be the end of 16. Okay, 17. So same idea here. So we're working backwards. We're doing the dilation of 2 first. We're doing the reflection of the y-axis second. Okay. We have points A, which is 3, 1, B, which is 2, -2, and then C, which is -3, 4. Remember, make sure you're reading the question. We're supposed to graph this, and then state the coordinates of that. So you have to at least do that minimum to get credit. We also need to show the work of how we're getting the dilation of 2 and then this. So dilating by 2, and this would be at the center at the origin, so it should be the O, 2 there, or the point 0, 0, 2. And all we're doing is multiplying by 2. So for A prime, it should be 6, 2. For B prime, we're multiplying by 2 to get 4, -4. And for C prime, we're multiplying by 2 to get -6, +8. Okay? Then we're going to do the reflection on the y-axis next, which means we're going to end up with a negation of the x-coordinate. So this should be -6, +2. For B double prime, it should be -4, -4. And then for C double prime, it should be 6, 8. And that's going to be our answer. We'd have to go graph the original and the final, so this one and this one to get full credit. So let's do this on the graph. So we start with 3, 1. So over 3, up 1. Okay, there's point A. We have 2, -2 for point B. And then we have -3, 4 for point C. All right. So we're doing the first one, which is the dilation of 2. Now it's centered at the origin. So all we're basically doing is counting to the point and doing that twice. Up 1 over 3, up 1 over 3. There's point A prime. Right 2, down 2, right 2, down 2. There's point B prime. And then we're going left 3, up 4. So left 1, 2, 3. 1, 2, 3, 4 up. And there's C prime. And that's it. That's how we do our dilation of 2, centered at the origin on a graph. Okay? We're going to get that funky looking triangle right there. Make sure you use a straight edge on a test, right? These lines are crooked, so I would lose a point for that. That lovely sloppy work right there. And then we're doing a reflection in the y-axis. So remember the y-axis is this, which by the way is the equation x equals 0, so keep that in mind. And then I'm going to count to the axis of 1, 2, 3, 4, 5, 6 to the right. So I go 6 to the other side. 1, 2, 3, 4, 5, 6. Okay. A prime is over here. That's 6 units away again. 5, 6. We go 6 units to the other side. We end up right there. And then B is 4 units away. We go 4 units to the other side. And right here. So, and then that's what this is going to look like. So that's C double prime. There's A double prime. And there's B double prime. Okay? And that's how you do that on a graph. Number 18, write the rule for the composition shown. So you can see I'm starting with this. So this is the first one. Okay, I got A, B, and C. So this is the second one. And then this is the third one, the really big one. So the first thing I'm doing, you can see the B is going over here. So that's being reflected over. And then it's in between A and A prime here. So it's right in the middle. So it's this guy here. That's my mirror. So this is my line. And that's an x equals line because it crosses through the x-axis and it's crossing at 2. So that's x equals 2. Then we're dilating, right? How big are we getting? So look at your points. You can see B prime is the point 1, 2, negative 2, negative 2. And it's turning into B double prime, which is 1, 2, 3, 4, negative 4. So negative 4, negative 4. So what are you doing to get from there to there? What are we multiplying by? Here it's easy to tell that it's 2, but maybe it won't be so easy. Maybe it'll be like 1.5 if it was like 4 to 6. Okay? So just make sure you keep that in mind, that you want to look at the actual coordinates to figure out what the dilation is. Okay? So the rule here for the composition, the first move is a reflection, lowercase r, and the line x equals 2. And the second move, okay, is a dilation centered at the origin with a scale factor of 2. So remember, we do the first one second and the second one first. So this is a dilation, the origin of 2, of a reflection in the line x equals 2. And this is how that's written. So we're working backwards. First one, second one. Okay? Going back over here, you can see that this is the original. That's my OG, right? This is our first move. That's our second move. So what are we doing to get from this to this? It almost looks like we're reflecting, except the A is off by a little bit. So it's not reflecting. What we're actually doing is we're actually turning. Okay? And you can see when I turn this 90 degrees, A now becomes a point 1, 2. We turn it back to normal. You see the A prime. That's exactly what A prime is, 1, 2. So the first move is actually a rotation about the origin of 90 degrees. It's 90 degrees because you're turning to the left to make that happen. Okay? Now, what are we doing to get from 1 to 2? We're translating, right? Because if we slide over the line, the letters are going to line up. So just pick one letter and map it over. It's 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4 down. So 5 to the right means capital T, 5, comma, and then 4 down is negative 4. Or, if you want to do the xy becomes x plus 5, y minus 4, that's also okay. So we write it as a composition. Remember, second one first, first one second. So the translation, 5, negative 4 goes first, of, we do the circle, capital R, and then origin, 90 degrees. If you just put 90, I'd take it because it's assumed to be the origin, but we want to try to make sure we're filling that in because we do have to list that every time, especially on the exam. Okay, number 19, draw the lines of symmetry. So the lines of symmetry, you can see like I could cut right through here, through this vertex. When I do, that would fold over and make that exactly in half. I can cut through these vertices right here. So that's the second line. And then I can cut through these vertices for the third line. Wow, that was terrible. Okay. You get the idea here, right? Now, not only that, I can also cut right through the middle of this side, through the middle of this side, and through the middle of this side. And so if we're counting, there's 1, there's 2, 3, 4, 5, 6 lines. This line we already counted, so I'm going to count it again. So there's 6 lines of symmetry going on in that hexagon. All right? We're ignoring that thing right there. Okay? So how many degrees of rotational symmetry? So when we're doing a rotational symmetry, what we really want to do, okay, and use a blank one for this, is we want to ask ourselves, if I start turning this, how many times can I turn this and have it look exactly the same, right? So if I turn it like this, that's 1 turn where it looks the same. There's 2 turns where it looks the same. So on and so forth, as I go all the way around the circle. So how many turns of this can I make? Well, if it's a regular figure, which means all the sides and angles are equal, the number of turns is the same as the number of sides. So if I go all the way around in the circle, it's 360 degrees, and there's 6 turns, so that would be 60 degrees, okay? And likewise, if they ask me like, I can turn 72 degrees, how many sides would that be? I would just take 360 and divide it by 72. And whatever that came out to be, in this case it's 5, that would tell me the number of sides, okay? So if you divide the 360 by the degrees, gives you the number of sides. 360 by sides usually gives you the rotational symmetry. This works for any regular shape. If it's not regular, meaning that the sides and angles aren't equal, you just got to kind of use your problem-solving skills to figure out how many turns you can make. So, for example, we talked in class about a rectangle would be 2 turns. Okay, if you had like an isosceles triangle, would only have 1, right? You wouldn't be able to turn it all the way back to normal, which would be 360. If you had something like a star, right? That would be, depending on how many of those are, that would be 5 turns or 6 turns. And then you would divide that out. Okay? That's it for today. Hope you guys got some use out of this, and I'll see you guys tomorrow.